welcome to my channel once again. If you haven't subscribed to this channel, do well to click the subscription button and turn on the notification button as well. Okay, now here in this video, we want to solve for the derivative of lane of the function x plus square root of 1 plus x squared. So the lane of the sum of two functions, alright? Okay, very nice. Now, when we do this, our aim is to get 1 over the square root of 1 plus x squared. So that simply means we're going to differentiate this and we're going to do some simplifications till we get to this, alright? Okay, very nice. Now we're going to make use of the tool that I've written here, that when we differentiate a lane of a function, it's just going to become 1 over that function times the derivative of that function with respect to x. So the lane of the function is 1 over that function, and it's 1 over whatever is in the lane function times, okay, the lane rule as well. So here, I'm going to apply that in this question, and I'm going to start solving. So the derivative with respect to x of the whole of that, alright, is going to become, just as it is written here, 1 over the whole of that is x plus square root of 1 plus x squared. That is it, alright? Times, now, f prime of x. So we're going to differentiate the whole of this. So we have sum of two functions. So the derivative of this one with respect to x is just giving us 1. The derivative of x with respect to x is just giving us 1. So we're going to have 1 plus, again, the derivative of this square root notation here. Well, square root is just, let me rewrite that in another form. So we're going to have 1 plus x squared raised to the power 1 over 2. That is how it can be written for differentiation purpose, right? Okay, so we just have the power 1 over 2. So this is more like a function of functions. So we are expected to use a chain rule. So we're going to multiply this in front, 1 over 2. And we're going to have 1 plus x squared. And we're going to subtract 1 from here. We have negative 1 over 2. And we multiply with the derivative of the inner function. So the derivative of 1 is just giving us 0. So we have 0 plus the derivative of x squared with respect to x is giving us 2x. So you have 0 plus 2x is just 2x. Okay, so this right here is going to come down because it has a negative exponent. So we just bring that in, we're going to have, let me just simplify this further. So we're going to have 2x divided by 2 times 1 plus x squared, and this raised to the power 1 over 2. Like this, or better still, you can say square root of that. I'm going to write it here, alright? So this is the 2, 1 over 2 is a, and this is just the 2x is up, and because of the negative exponents, we bring the whole of this down, like this, right? Okay, very nice. So these 2 and these 2 can just cancel, and we just enter with x divided by, this is just square root, right? Square root of 1 plus x squared, like that. And we are done with the differentiation. Very simple, huh? So we just go ahead and do some simplifications now. Okay, now here we just observe 1 plus the fraction, okay? So we can just go ahead and take some LCM, we multiply this with the 1 here, and we divide it by just this time, the denominator, which is just 1. So we're going to have 1 times that square root of 1 plus x squared, okay, plus x divided by square root of 1 plus x squared. And we still multiply with the whole of this, that is just 1 divided by x plus square root of 1 plus x squared. Like that, right? Okay, so multiply this with 1, add it with this, and divide it by the LCM. You know, it's more like taking the LCM. Okay, now we can just go ahead and multiply these two fractions, right? In the numerator, we have something nice, but in the denominator, we're going to need some more eyeballs. So here we're going to have square root of 1 plus x squared. This square root actually covers that. Plus x in the numerator, and in the denominator, you know, we're having the rational function here, a square root function here, and here as well. So we can multiply this with the first term here, square root x times the square root of 1 plus x squared. So we just have it x times the square root of 1 plus x squared. And again, square root of 1 plus x squared times square root of 1 plus x squared, that is square root of 1 plus x squared all squared. So that is just plus 1 plus x squared. You know, the square root and the square root, they cancel, and just enter with the radical function. So you have it here, right? Okay, so you can take this up and continue solving. Now, in the denominator we're having this, and the numerator we're having that. Well, since we can't simplify further, but we need to get here. If I multiply the numerator and denominator by the conjugate of the numerator, because the numerator looks simple, but yeah, the conjugate of the numerator, that is, just change this place to negative. Yeah, just to go ahead and rationalize only the numerator. So we're gonna have multiply numerator by its conjugate. Multiply. Okay, let's just show you the steps. So we're gonna have 1 plus x squared plus x, and we multiply it with square root of 1 plus x squared minus x, right? And in the denominator, the whole of that is x times the square root of 1 plus x squared plus 1 plus x squared. Let me put this in brackets so it will look simple. Okay, we multiply everybody by the conjugate, so that we just cancel, we just get back what we had originally. So we've actually not changed anything by changing something. Okay, now we're going to multiply each of the terms like normal expansion. So this and this give us v squared, this and this are the same, so we just take the square of that. So that's going to be 1 plus x squared. The square of it takes care of the square root. And again, this times this will just give us negative x squared. Why am I not multiplying this and this? Because the two of them will cancel out. This is just negative, and this is going to be positive. The two of them will get to 0. And the denominator, well, this times this is going to give us that square, 1 plus square root of 1 plus x squared times square root of 1 plus x squared. Where x was here, we're going to have 1 plus x squared, like that. And again, here and here, we're going to have negative x squared times square root of 1 plus x squared. It's just more like just an expansion. And in this other case, we still have plus 1 plus x squared times 1 plus x squared raised to the power of 1 over 2. This one I'm just changing it from square root to 1 over 2, which is just the same thing. And in this other case, we just have x times 1, we have x, and x squared times x, we have negative x cubed at the end, like that. Now, in the numerator, we're having only 1. Wow. We've achieved 1 in the numerator, and in the denominator, if we multiply this with 1, we're going to have x. And here is very nice, negative x. So we can just go ahead and do some cancellation so that we write down a simple term. So this will cancel out with the x. That is negative x. And again, x times x squared, that is going to be x cubed. And we're having negative x cubed here. And we just cancel out nicely. So we can just cancel the whole of this. Now, we enter with the remnant, right? So we're going to have, here we're going to have negative x squared times the square root, just write square root of 1 plus x squared. Now, on this other side, I'm having, this is just square root. Let me write it as it was, because it will help us like that. Okay, square root of 1 plus x squared. Now, we multiply 1 with that, that will become plus 1 times square root of 1 plus x squared is just square root of 1 plus x squared. And again, this is positive x squared, so we just multiply x squared times square root of 1 plus x squared. So, having this and this are equal in magnitude and opposite in sign, so they will cancel out. And what are we just left with? Well, we're just left with 1 divided by square root of 1 plus x squared. And like this, we have shown, we've shown. So we've shown, or you've already just proven any of them. Okay, that was a long proof, isn't it? Alright, so that's it, and that's what you get.